Okay, so what we have here is on the very left, I have a random curve with 2 points. So if I put a line through those 2 points, it would be a secant line, and I would calculate the average rate of change. However, average rate of change isn't really what we're looking for. Okay, starting at this point, we're not really looking for average rate of change at all for the rest of this unit. We're focused on derivatives, which is used in calculus, which is instantaneous rate of change. So we want to get the slope of a tangent line. A tangent line is when there is 1 point on the graph rather than 2 points. So what we want to do is we want to take those 2 points and we want to get them closer and closer together so that they become 1 point. So notice here what I've done is I've labeled the x values of each of those points as x and x plus h, so that the horizontal distance between the two would be that extra h. And what we want to do is we want to get h closer and closer to being a value of 0. If the 2 points get closer and closer together so that it forms 1 point, then we're making h become closer and closer to 0. Now, if you think about something getting closer and closer to 0, you're thinking about a limit, right? The limit as h approaches 0. You're not going to get it to 0, but if you can get those points super, super close, then it's approaching 0. So our definition of a derivative, which is below, is an actual limit as h approaches 0. And the formula that you have to get the limit of is the slope formula. So the slope formula, of course, is the change of y over the change of x. And what I've done is I've replaced the x2s and y2s and y1s and so on with what I labeled on my graph as x1, y1, y2, x2, and so on. And if I do that, okay, I can simplify this formula just a little bit. On the denominator, I have x plus h minus h. So those h's cancel, and you get just an x on the denominator. The numerator, I can't really cancel those. Those are two separate y values. And therefore, we are finding the derivative, which is as those 2 points get closer and closer together, it is calculating the slope of the tangent line. Or it's still a secant line because it's still two separate points, but those 2 points are getting closer and closer to become just 1 point as h approaches 0. Now, in the next video, what we're going to do is we're going to take a look at actually doing some examples with this.